Here we go, last section of chapter 7. And these are where we're going to talk about unique quadrilaterals that are not parallelograms. Okay, so these guys are not parallelograms. Remember, parallelograms has opposite sides congruent. These guys are lacking that trait. First one we're going to talk about is a kite. And these guys are like our kites. We like to fly in the air. Probably not going to fly kites right now because it's cold and rainy outside, but you know what? There we go, there's our tail. But with a kite, it's not a parallelogram. That's the first thing we have to remember. A kite is not a parallelogram. But it does have some situations that are unique. The sides that are next to each other are going to be congruent. That's what makes a kite a kite. Okay? So it's not a parallelogram, but the sides kind of next to each other are congruent. What do you want to say? The small sides are next to each other and the big sides are next to each other. And the situations that happen here is diagonals are perpendicular. So we are going to have, actually I'm going to, hopefully that helps. So your perpendicular diagonals. So we still have a 90 right there. And the long diagonal bisects its angles, okay? So these guys are congruent. And these guys are congruent. You'll notice the top angles are not congruent to the bottom angles. Why is that? Well, your smaller sides are going to have a bigger angle up there than your big sides. So these two angles are not congruent, but those two little halves get cut in half by the long diagonal, and these guys get cut in half. The other thing that this long diagonal does is it bisects the short diagonal. Okay, so that means this little guy here, that short diagonal is cut in half. Okay, so kites have have a few properties you got to recognize. Diagonal's perpendicular. The big diagonal bisects its two angles, and the big diagonal also cuts the small diagonal in half. You'll notice we don't really know much about the big diagonal, other than what it does, which is it cuts some angles, and it cuts the diagonal in half. Okay. And last but not least, if you want to add some maybe bows to your little kite string, that'll be kind of flashy. Oops. Boom, there you go. There's our kite string. And last but not least, we're going to talk about trapezoids. Trapezoids are not parallelograms. Okay. And with the trapezoid, you probably think of something kind of like this. And that's true, almost like kind of a bar gold, something like that. Parts of a trapezoid we gotta know is we have two bases that are parallel. The other guys are called legs, kind of like a triangle. And a trapezoid has exactly one set of parallel lines. Keyword is exactly. Okay? Not one or more, exactly. Okay, exactly one set of parallel lines. Now, I'm gonna be honest. With the trapezoid, we don't know many special properties about a trapezoid because these legs don't have any special relationship. There's not much we can do with a normal trapezoid. However, if we knew these legs are congruent, then we can pull out some information. So, if legs are congruent, remember how what we call a triangle with two congruent sides? It's an isosceles triangle. It's the same for a trapezoid. If two legs are congruent, we call it an isosceles trapezoid. So this is a special type of trapezoid. So with the isosceles trapezoid, I'll draw a picture of it. A big one. The key thing is two legs are congruent. And we've still got these guys parallel. So legs are congruent. Okay. Now, the other things that happen is these angles down here are congruent. And the angles up here are also congruent. Okay? So you're going to be able to get a lot of information if you do know something's an isosceles trapezoid, because these guys we call them the base angles. The angles next to the same bases is what it's saying. So these angles are the same at the bottom base. These angles are the same with the top base. And then last but not least, diagonals are congruent. With an isosceles trapezoid. One other thing to note is these two angles are supplementary. Remember, think back to chapter 3 with parallel lines. We got some parallel lines right here. That means this guy and this guy are consecutive interiors, and they would add to 180. So if you're given one angle in a trapezoid, in its isosceles, you couldn't figure out everything else. Bottom guys are the same. This guy and this guy add to 180, and then these guys are the same. So it's kind of a nice problem where if you get one answer, you can kind of like knock going over a domino, and you can get the other pieces as well. Now there is one formula. It's not too bad. And this formula works for either isosceles or normal trapezoids. It's just called the median of a trapezoid formula. And this is similar to, I think it was the triangle mid-segment formula, something like that, from last chapter. So what a median of a trapezoid does is it's going to join the midpoints of the legs, and it's going to be parallel to the bases. So the median joins the midpoint, it's going to be parallel to the bases. Picture, picture. What do they say? A picture's worth 1,000 words. That's a lot of words. No way I'm writing that many words today. So you're going to notice if this is my trapezoid, this is not an isosceles trapezoid, that's okay. And we've got, this is my median, so that means this guy and these guys are cut in half. And then all these guys are parallel. Okay, so take a second, write that down, and then we're going to talk about the formula. We know the median's in the middle. Now the top guys are just bases, but because we're going to put these guys in a formula, we're going to call the top guy B1 and the bottom guy B2. If you flip those around, it's not going to matter. Okay, and the deal is the median equals base 1 plus base 2 divided by 2. Boom. Bop, there you go, the end. So the median's halfway in between those guys. Okay, and that's it. So once you have that down, we are done with chapter 7, for the notes anyway. And I'm going to get that example video up next, so you can check that out. Thank you for watching.